here we are, talking about final exam. So, a lot of easy questions, some of them ridiculously easy. Write the fraction in lowest terms. Notice that this is an improper fraction. That's where the numerator is bigger than the denominator, right? It's a number bigger than 1. Now, I realize I'm not ignorant to the fact that saying mixed numbers are for elementary school children and chefs. It's designed to make you feel like, I probably shouldn't use a mixed number anymore if people in the sciences feel that way. And they do. You don't even have to get into a very sophisticated science, and people will stop using mixed numbers. The reason is because a mixed number, like 1 2/3, really and truly means 1 plus 2/3. If anything, we meant to say this, but this isn't what they wanted. They want a single fraction, improper or not, in its lowest terms. So, Carly, what should I do here to simplify this thing?
Take the zeros off.
But what happens there mathematically?
The tens. So the tens.
160 is what times what?
16 times 10.
Exactly.
So you take the 10 out of both, that gives you 16 over 13. Or divide by 10, if you will.
Times 10 over 10.
Yeah.
And the 10 over 10 is 1. And then do 16 over 13 reduce?
No.
No, why not?
They're prime. Well, 13 is.
13 is prime. So 13 is prime. 16 does not have any factors of 13, so we are done. And the test consists in many problems of this difficulty level. Multiply. Write the answer in lowest terms. Those instructions are in reverse order from what they should be. You should not multiply and then put it in lowest terms. You should cancel first and then multiply. It's easier. Does 24 have any factors of 8? What are they? 3. 3 times 8 is 24. You should write this first number as 7 over 3 times 8. And this second one is 8 over 35. Does 35 have any factors of 7? It's 7 times 5. So we should be writing 8 over 7 times 5. Now, if this were one big fraction, here I am. I'm going to now multiply them together. Well, that just means that there's one big division bar. And I should do the cancellation first. It just makes everything easy. The 7s are going to cancel, the 8s are going to cancel, and now you can tell me the answer to this, and you didn't even pick up a calculator. Say what? 1 over 15. Divide. Write the answer in lowest terms as needed. Again, those instructions are in the wrong order. We shouldn't divide first and then put it in lowest terms. Our first step should be to reinterpret this crazy division symbol as a product, and then factor it, cancel, and see what we're left with. That is the best way. So this should really be 21 over 4 times what? 24 over 7. And then the 21 is 3 times 7. And the 24 is, it is 3 times 8, but I would like it to be something that has a 4. 4 times 6. So 4 times 6 over 7. Now I will multiply the two together and get 3 times 7 times 4 times 6 over 4 times 7. And we have the same thing happening to us. You can tell me the answer now. Look, did you ever really think that you would be able to be looking at these the division of these two fractions and able to figure it out without a calculator? It's sort of, once you realize that you're able to do this, it should feel good. We get 18. And when we can work without a net, like by way of not doing things with a calculator, we have a stronger number sense. And then when we're on the job, we're able to detect when things aren't quite right. Yeah. I had a student submit a signature assignment in statistics where they had to use some statistical models to figure out the shoe size of someone that was 68 inches tall. And they told me that their estimated shoe size was like 168. Well, that's a big shoe. Shaquille O'Neal wears a size 22. So that must be like, I don't know, a giant wearing a size 160 something. You have to have that number sense that something is not right and be able to detect it and not just blindly trust your calculator or even your calculations. List the elements. X is a natural number less than 10. What is a natural number? Say what?
Numbers.
What's a natural number? What is an integer?
Any number.
Any number is not a natural number.
Oh, no, the numbers. All real numbers?
No.
Real numbers.
The real numbers are, the natural numbers are contained in the real numbers. Here's my real numbers. Here's my natural numbers. If this is my number line that consists in all real numbers, then the natural numbers are just sometimes also called the counting numbers. They call them natural because they're the ones that first seemed to exist before anything else. No one ever really believed that this was completely filled in right here in between 1 and 2. And they didn't have a concept of 0, so you have to picture yourself 5,000 years ago, and you need to count how many sheep are in your flock. 1, 2, 3, 4. Those are your natural numbers. They existed naturally without anyone having to know anything. Birds can count up to like 6 or 7 or 8 or something. They would put out different numbers of seeds in front of them, and instantly the bird would go to the pile that's bigger. But only up to a certain number. After that, they couldn't discern the difference. So that makes them natural in that regard. Then if I want all the natural numbers less than 10, should I include 10? No. So the numbers are 1, 2, 3, 4, 5, 6, 7, 8, and 9. There's the answer. And it has to start at 1. Can't have 0. If I throw in 0 and all the negatives, those are the integers. Absolute value. What does absolute value mean again? I'm teaching a pre-cal class. and absolute value comes up every time you turn around. And I whip these guys with it just over the head. Bang, absolute value. And I ask them the hardest questions and always sneak it up on them. Granted, you guys aren't doing pre-calc, but this operation is deceptively simple and simultaneously extremely delicate and complicated. All it really means is the positive version of this thing. It means if there's a negative, rip it off and put it in the garbage can. What does this add up to? 14. Recite what this says to me, but without the absolute values. Like, go ahead and simplify what is the absolute value of minus 7. Tell me what it says.
Negative 5 minus 7.
Yeah, minus 5 minus 7. And that's what?
Negative 4.
Find the quotient. 0. How do I know it's not undefined? Why is this here as a choice? What are they getting at? What are they trying to stump me about?
The 0 is not in the denominator.
Right. If it was a minus 15 over 0, then this would be undefined. What about this thing?
That's 1.
Here's how you know it's not. 1 is because this really says, and this thing is undefined right here. Okay. Otherwise, it looks like it could be 1, but 0 is the only number that does not have a multiplicative inverse. And the reason is because 1 over 0 is undefined. So anytime there's a 0 in the denominator, no matter what is in the numerator, it is undefined. And the only reason that this thing came out 0 here was because it was a 0 in the numerator and then not 0 in the denominator. Week 1 question. It seems like there's just a lot of symbols going on, but it's not that bad. You look at things in terms of where the terms are at. That's a term, and this is a term. The terms, it's this term plus this other one, is what I see here. And so you can work on the terms in any order you'd like. Probably I would say, I see that these are both negative, so then that quantity will be positive. It'll be positive 7 times 9, 63. So then this part right here is 63, and then there's that minus symbol. And then this part up here is going to be a negative number. It'll be 7 times 6 squared. Okay, well that's unpleasant to do in my head. Go ahead.
Negative 252.
Negative 252. Counting on you to be right. It'd be 36 times 7.
Yeah.
If I was desperate to do that in my head, I'd say 7 times 30 plus 6, like that. And then that'd be 210 plus 42. All right, so, and then when I combine these together, I get 315, negative 315. So I see 250, a minus 255 minus 60. Well, that's a minus 255 minus 50 minus 10, so it's minus 315. Yeah. When they say, what is the solution set, they are asking us for the collection of numbers that solve the equation. They do not want you to say that there is an equation that goes here. You can't say x equals whatever and expect to get it right. Okay? So, what should I do you think? Distribute? Combine like terms? Additive inverse? Multiplicative inverse? These 4 steps solve every linear equation. Okay, so I'll have 7x plus 28 equals to 9x minus 18. There are no like terms to combine. When we talk about like terms, we're talking about on just this side of the equal sign and just this side. And these aren't alike, so we're done there. Then now I want to do use some additive inverses to bring the x's together and bring the numbers together. So what do you think would be the smartest thing to do? To subtract the 7x or to subtract the 9x?
Subtract the 7x.
Yes. Why?
Because then it keeps it positive.
Very good.
The same way.
That's what I like. So if I could eliminate having that dangling minus hanging out front, I want to, because it just reduces the chance that you will make a mistake somewhere. So bang, there I am. I have subtracted 7x from both sides. There it is. I don't actually need to rewrite the equation at this step. I mean, I could, but I could also just finish it. I could just finish my additive inverse operations. If I have subtracted 7x over here, I should not subtract 28 now. If I did, I'd have 0 over here. I should add this 18 to both sides. If I add 18 to both sides right here at this step, then I will have made the 7x's cancel and these 18's cancel. And I can save myself a bit of writing. I would have that 2x is equal to 46. And in turn, x is 23. Should I type x equals 23? No. I should just type the number 23. Solve the equation and check the solution. They're not going to have any idea if you check for the solution, but checking it will help you to know that you did it right. This is a one-step problem. Maybe 2-step. Actually, no. This is a one-step problem.
Multiply both sides by negative 15 over 13.
Yes. Negative 15 over 13 is the multiplicative inverse of negative 13 over 15, because it's the only number such that when you multiply these two together, you get 1. So the left side will say 1 times x, and the right side will say negative 7 times 15 over 13. Okay. How do you want to handle this 7 times 15? Well, that'd be 7 times 10 plus 7 times 5. So it's 70 plus 35, that's 105. So I'd have negative 105 over 13. Can anyone justify for me whether this will simplify?
13's prime.
You say no. You say no. Be careful though, because even though 13 is prime, what you really mean is that this prime number does not appear up here as a factor, right? Because if this was a 26 instead of a 15, it would reduce. Okay. All right. So minus 105 over 13. Solve for n. This is a week 1 problem. Yet, it's still widely missed. We want to solve for n. What's my first step?
Get n on one side.
And how should we do that?
I would subtract 4b.
Subtract 4v. We're using additive inverses. So if I subtract 4v on both sides, I have t minus 4v equals to 4n. Now what?
Divide by 4. So it comes out to n.
Divide by 4, and then you have it solved for n. So tell me what it's going to say on the other side.
Equal to 1 over 4b t minus 1.
Say it again.
T minus 1 over t minus v equals to
Yep.
N equals to t minus 4b over 4.
Okay, tell me another way to say it, where it's not one big fraction.
N equals.
What is it? What do I need? If I want to add 2 fractions, what do you need?
Same denominator.
Same denominator. Isn't this 2 fractions that have been added together?
Oh, yes.
Take
So
them apart.
T over 4
Minus v.
Yeah.
And either of those is acceptable, and quite often one of them is easier to look at than the other. This problem could be way harder than it is, but they were nice to you. 16 increased by 3 times a number. You just decode it. 16 increased by 3 times a number. What in the world should we do? Yeah, 16 plus 3x. It says to take this number here, and we have this quantity, and I'm going to increase it by something. What is it? It's 3 times a number. And we know it should be x, as it says up here. Use x to represent the variable. But x is not that special. Could have been anything. Find the x and y intercepts. Ooh, you should. It would be, I don't know if you should. It would be awesome if you could look at this right away and know what the x and y intercepts were. If you know, go ahead and tell me. And the entire, there's something special happening here that tells you instantly what those intercepts are. And I bet money that your question is just like this one. This is number 13 of 33. Ideas? Is 0 a point on the plane?
0.0.
0, comma 0.
Or 0.0.
And which intercept is that? X and y. If you ever have the x-intercept as 0, 0, it must be the case that it's the y-intercept too, because that's where the x-axis and y-axis cross. So this is a line that goes through the origin. Both the x and the y-intercepts are the origin. All right, and don't mess up and think that you can not use the parentheses. You need it for it to qualify as an ordered pair. Now they want the graph. Uh-oh, what am I going to do?
Just do 13.
Huh? So how should I mean, it takes 2 points to define a line. Yes? What's the strategy? What should you do?
Just to pass through the.
It's going to pass through the origin. So we know one of the points, 0, 0. I need another point. That whatever it is, it must satisfy this equation. If you can pick me an x and a y that satisfy this equation, then those are the coordinates of another point on the line. And we'd be done. If x is 1, then so is that enough? That's not another point. What's true is that this is a line, so its domain is all real numbers. You can put 1 in for x, and there will be a y. What's up?
Could x be -7 and y be 1?
Yes, it could. That's wonderful. So that's just kind of an observation that, if I put a 1 in for y, then I'm just looking at that number 7. It's brilliant, actually. Then make x just be the additive inverse of this number over here. So -7, 1. I like that. We didn't even need to resort to slope. Like, the whole point of that was to not have to go through the motions of solving this thing, to put it in y = mx plus b form and then read off the slope. We certainly could have. You'd get that the slope is -1/7. So from this point here, it went down 1 and over 7. That's the line. Y = 4x. Notice that this line here, y = 4x, is in the same spirit as this one. Because because the b in the y = mx plus b is 0 in both of these equations. So if they were to ask me what the x and y intercepts were here, again, it would be the origin. And what's the slope? 4. And if I were to graph this, well, then I've got to go through the origin, because it's just y = 4x plus 0. So the y coordinate of the y-intercept is 0. And then give me another point. Saying 4 on the y is insufficient to describe a point, because there's a whole bunch of points whose y coordinate is 4. 4, comma 1.
Oh, 4, 1, sorry. Here's
Or you were right, 1, comma 4. Sorry, I meant it would, if we were going to put the 4 first, it'd be 4, comma 16, because it's x, comma y. Okay. So here we've gone up 4 and over 1. Solve the system by substitution. Do not do that. It is the worst possible way to handle one of these problems. Or not the worst possible. The worst possible would be to sit there and guess. So substitution then is the second worst strategy. The very best thing for you to do is elimination. Elimination is where it's at. All you would need to do is add these two things together. It's just like if you were adding two polynomials together, except there's an equal sign. It's no big deal. We're just going to add the numbers together. But I want to add them together in such a way that one of these variables ends up disappearing. It appears that the x's are going to be the easiest, right? And this is an equation, so I can multiply on both sides by whatever I want, and it will still be true. -2. I should multiply on both sides by -2 of just that bottom equation. So -2x minus 10y equals -104. Now when I add these two things together, the x's will cancel, right? So I would have minus 14y equals to a minus 126. Isn't it 9? So now y equals 9. I did that by saying y is a minus 126 over minus 14. Well, for sure, the negatives cancel. The 14 I know is 2 times 7. And the 126 I know to be 2 times 63. And then I said, well, 63 is 7 times 9. So the 2 and the 7 cancel on top and bottom, and you're just left with 9. Should I type in y equals 9? No, heck no. I should just give it the object for which the system is satisfied. But even typing in 9 is not what they want. They want an ordered pair. They need both the x coordinate and the y coordinate. So now that I have the y coordinate, what should I do? I know that y is 9. So what do I do?
Well, 9 into the so for 8.
Plug it back into one of these up here, whichever one looks the easiest. Would you rather put it in the bottom one or the top one? The bottom. Okay. So x is going to be equal to 5 times, x plus 5 times 9 is 52. And 5 times 9 is 45, so then x would be what, 7? Okay. So my answer will be 7 comma 9. And it'll be in parentheses because it's an ordered pair. Apply the rule for exponents if possible. This should be a no-brainer. Five to the 10th power. Be careful that you read the instructions. It does not say to explicitly find the integer that 5 to the 10th power equals. It's going to be a massive integer. This is what they wanted. They wanted for you to simplify what the exponent would be. You guys should know this now from studying logarithms. 1. We answered this question earlier. 3 to the 0 is 1. 10 to the 0 is 1. Any number you'd like except 0 to the 0 power is 1. What number is this?
Really quick.
Yep.
Sorry. On number 15 for the solution set, we don't put parentheses, correct? In the answer. Or should
Oh yes, we do.
we do? Okay.
Because why? 7. If I just put 7 comma 9, that's a list of 2
Because
numbers.
it's an ordered pair, or it's a
Yeah.
Okay.
How many things are in this set? One thing.
Okay.
There's one solution. But if it just said 7 comma 9, that'd be 2 things.
Okay. Thanks for clarifying.
What's this number? This is an integer. Which one? It says type in integer or a fraction. It's true, it is 2 to the 5th power.
32?
It is 32, but you're typing something there. You should be, no, behind.
Oh.
You should be 2 cubed is 8, yes? Times 2, times 2. You could do that like nothing. Okay,
What was the answer?
32. This one they wanted simplified in just our notation. So what would it be? not times.
Three to the first. Or no, it's negative, so it would be 3 to the 19.
3 to the 19.
Oh.
3 to the 19. Yeah. .6 times 10 to what?
Four. Let's see this.
I didn't adhere to any significant figures here.
No, but it reminds me of six.
It does. If we had to do that, and we should have to do that, is my answer right?
No.
No.
It would have to be the other one.
It would have to be what?
3.6 times, or x, x.
Times 10.
I don't put X because I don't like it. We don't need it.
You know what I mean?
I do. You mean times.
Yes.
So say that.
My brain is.
3.6000 would be paying attention to the significant figures. Because it's like
Times two.
there is a degree of precision here. What we would be indicating is, so this would be like 36,000 something. Like how much did your car cost? It cost this. But this is, it cost 36,000 precisely. Not 1 penny more or less. Right on the dollar. But this is like about 36,000. It could be hundreds of dollars different. And so that's what we say when we're talking about significant figures. It, of course, is very important if you're doing like medication compounding to know that you're paying attention to those significant figures. So there's a multitude of ways to write this. If you use the X symbol on your keyboard, it will be marked wrong, not by me, but by them, because they can't understand what you're saying. However, this notation is unmistakable because it's the product of 3.6 and 10 to the 4th power, which is 36,000. Factor out the GCF. Oh, that's an easy one. They want us to type the answer in factor form. What should I say? 4 times
Plus 2y.
that problem is the same problem as this problem, just a little bit more sophisticated. But it's the exact same stuff, right? Look around at these numbers. This one has a 6. It is 6. Does 54, can 54 be written as a product of two numbers where one of them is a 6? What would it be? 9 and 6. And what about 18? 3 and 6. So 3 times 6 times x squared minus 9 times 6 times, and can't I say that x cubed is x squared times x? Of course. And then it'll be plus a 6 x to the 4th, but instead of saying x to the 4th, I'll say x squared times x squared. Well, now I can explicitly witness the GCF in each one of these terms. This is the advantage of making this writing. So my GCF is 6x squared, and when I factor it out, I can see, plain as day, what the rest of the symbols will be. I mean, they're just the ones that don't have the box around it. If you do this step, there is absolutely no need for that very common thing afterwards of, ooh, let me distribute it back in and see if I get the same thing. It's just not needed because you would get exactly this writing if you did that. So 6x squared times 3 minus 9x plus x squared. All right, let me pause for a second. So, Rosalinda, which questions from your list have we not done yet so far?
From my list,
Yeah, which ones from your list have we not done so far?
we've done all because it was up to 20, which I had to use.
Okay. So we've done them all? Okay. What did you think? Did you have any questions from what we did? Do you see where the difference is between what I did and what happened to you?
Like number 4, I just put a 0 in front of 1.
Uh-huh.
And then on number 1, I broke down the 15 over 30. And then on number 9,
When is this assignment due?
again.
Tonight? The final's due tonight? Just curious. I'm pretty sure that while it's due tonight, there's like some massive, there's like a huge number of days that, an undetermined number of days after that would still accept it late with no penalty. So you could take it again. Anyone could. Probably as many times as you want.
Yeah, it's unlimited.
All right. So,
I can take it again?
of course,
Oh. I didn't know.
if you go to my stat, or not my stat lab, but my lab math, it tells you when you go to assignments that how many attempts you have on the assignments, and I think it has an infinity symbol there. All right, factor by grouping. Do we need to take a break, or should we just finish this? We've got 10 questions. Power through?
Yeah.
Okay. Factor by grouping. Well, that means for us to think about it like this. Okay. So from this first pair, it looks like just a 5 factors out. So it'll be 5 times 7a plus g. And then from the second pairing, I think a q factors out. So q times 7a plus g. And the only way that factoring by grouping succeeds for you, or is even worth looking at, is if at this stage they both share that common term in parentheses. So you can then factor out that thing that's in the parentheses, and we would get 5 plus q times 7a plus g. And a question like this is worth looking at because we would need such a strategy if we intend to use our technique of the A's and the B's in order to factor a quadratic. And what is the GCF usually of a quadratic that we can apply that technique on? Huh? Not sure. What's the GCF of this thing? Do each one of those terms have x's? No. The GCF is 1. They would all at least need to have an x. If they all had an x, the GCF is x. So the GCF is 1, and if the GCF is 1, then it is one of these polynomials that we can factor with the method of the A's and the B's. So And they even give us a hint here. One of those numbers is going to be 6. Right? This thing is half factored for us. So 6 plus b should be a minus 17. And 6 times b should be oh, it's because this is supposed to be a minus 6. Minus 6 minus 11 is minus 17. And minus 6 times minus 11 is positive 66. Now the leading coefficient here is 1. So that means that once we find a and b, then it is exactly those numbers that go next to the x. That's why this one is a minus 6. The other one is x minus 11. And that is one of the benefits, or not benefits, but that's one of the things that makes the polynomial easy to factor when it has a leading coefficient of 1. Write the rational expression in lowest terms. What the heck does that mean? Doesn't it mean factor out a 7 up here? Can I factor out a 7 down the bottom? What would I get?
9
Okay. Is this the most ideal situation for me to complete the problem? Is everything completely factored, in other words? What is the GCF of 9 and 3? 3, which is not 1. Until the GCF is 1, you can still factor. So we should say 7 times k minus 3 over 7 times 3 times, this would be like 3 minus k. Is it ideal now? Really? I could do it right. What will you? What's the answer then? Negative 1/3. Why is it negative? You can factor a negative out of this guy down here, right? This basically says minus k plus 3. Factor out a minus 1. Factor out a minus 1. This is saying 7 times k minus 3 over negative 7 times 3 times k minus 3. If I distributed that 7, if I distributed that negative back in, the k would be negative and the 3 would be positive. That's what it says here. K is negative and the 3 is positive. So now, 7s are gone, k minus 3s are gone, we get minus 1/3. I want everybody to do well, but somebody needs to talk to whoever wrote this thing. It's a little bit on the easy side. 3/8 plus 3/8. I see that, and I see the same thing as 3 apples plus 3 apples. 3 students plus 3 students. I mean, this is just saying 3 things plus 3 things. It's like it didn't matter that it was over 8 or those things. All that's happening is that those things that we see are the numbers, is the fraction 1/8. Right? The 1/8 could factor out, it just says 3 plus 3. So you'd have 6/8. Is 6/8 simplified? No. Because another alternate way to do this is, look, these are the same number. So 3/8 plus 3/8 just says 2 times 3/8. You could cancel the 2 and the 8. You know? 3/4. What's the index of this thing I'm looking at here? What's the index of this radical? Five is the index. So we can rewrite such an object as the thing that's inside the radical to what power? I want a rational exponent. What's that exponent? Do we know what this would be without having to tend to that? -4. The 5s match. Them matching has something to do with them just collapsing away to nothing. What kind of exponent would it take right here so that this just came out -4? 1/5. Evidently, the nth root of something is that something to the 1/n power. Okay? And this observation is going to come in handy on the signature assignment. And it's super handy, like on a calculator that has exponents but doesn't have radicals, or just making sense of things that I know that I used to know a way to estimate square root of something using that, but I forgot how to do it. I need to look it up again. But it's a handy notation. So this would be -4. What if instead of having those 5s there, it was 6s? What if then what if that stayed a 5 and this one out here became a 10? What if it was 10th root of -4 to the 5th power? I like how you're thinking, but it wouldn't. You have -4 to the 5th to the 1/10. So it would be a minus 4 to the 1/2. The answer is 2i, where I is the square root of -1. So it's a negative number in the square root. It won't be a real number. Got to have a positive, got to have a non-negative number inside the radical for it to be a real number. Oops. So you can use that strategy of the rational exponent to answer this one in a hurry. This is x to the 4th to the 1/2. So you multiply the exponents, you just get, say it. Yes. Because it's 4 times 1/2. Product rule, I don't even know what that means, but yeah, it's 3. I think they just mean that the radical of the products is the product of the radicals. Or you could say this is 3 to the 1/2 times 3 to the 1/2. So you have 3 to the power 1/2 plus 1/2, which is just 3. There's a bunch of ways to look at it. Solve by completing the square. No one's looking over your shoulder to see if you're completing the square. We can certainly do it, or you can just use quadratic formula or whatever. Right? So I'll do it by completing the square because it's a neat thing to do. So 2 plus, so the first thing that ever has to happen is you have to have a leading coefficient of 1. So the 2 has to factor out. You get x squared plus 3/2 x minus 1/2 is what is equal to 0. And then I'm going to look at this number in the middle, which is the 3/2. And I want half of that number squared. Half of 3/2 is 3/4, and then I'm going to square it. And then I need to turn right around and subtract that 3/4 squared. But instead of writing 3/4 squared, I'm just going to figure out what it is. It's 9/16, right? So right here I've added 9/16, and now I should turn right around and subtract 9/16. And then I still have my minus 1/2, and this whole thing is equal to 0. And the beautiful thing here is that by way of this strategy, these first 3 terms will always collapse. It's always a perfect square. So what you end up with here is x plus 3/4 squared. I still have that 2 on the outside, and all I need to do over here is figure out what is a minus 9/16 minus 8/16, right? Because isn't that what minus 1/2 is minus 8/16? So this would be a minus 17/16. Now I can distribute that 2, and I'm getting that this is 2 times x plus 3/4 squared minus 17/8. This is the equation of a parabola, and now the power of writing it like this is I can see what the ordered pair of the vertex is. The vertex of this parabola is at the point minus 3/4, comma, minus 17/8. So there's minus 3/4, and down here is minus 17/8. And that is where the vertex is at that ordered pair. And it's going to go up like this because the leading coefficient is positive. And when we solve this thing for 0, we will have those 2 points where it crosses the x-axis. So I would get x plus 3/4 squared being equal to 17/16, and then I take a square root on both sides, so that way x plus 3/4 is equal to plus or minus the square root of 17 over 4. And now you're done, because it's x equal to a minus 3/4 plus or minus the square root of 17 over 4. You would get exactly the same thing if you did the quadratic formula, because that is where the quadratic formula came from, was from us completing the square. And of course, this jives perfectly with what I said about this being where the vertex is at, because you can see it in this solution that we had to go out here to minus 3/4 and then look to the left and look to the right by the same quantity. It says, oh, we decided before that we could use the plus minus symbol, which is cool. It saves us some typing. So it's a minus 3/4 plus or minus square root of 17 over 4. And there's my numbers. So I completed the square. I don't expect really seriously for you guys to be able to do it. You can certainly try. And the quadratic formula just hands it to you. But you would still have to be able to run that thing correctly. Solve for x. How should we do this?
Get the same base.
Huh?
Get the same base on both sides.
Is that what we did here? Let me tell you, that would be a heck of a thing if you could get this 1/5 written as e to some power. It would be monumentally difficult to be able to just see what that is. However, this process works every time, no matter what, and is the reason for studying this stuff at all. The gimmick of seeing, so like the only way you could solve this type of problem in that strategy is if this was a power of 3, and so then that is the exact reason that I would not even bother studying such a problem. It's just too trivial. These are the type of problems to study, and not 3 to the x to the 9, because you could immediately see that x was 2 if this was 9, right? You see it right here. So I would, unless it was crazy simple to do, I wouldn't even mess with it. This one, is it crazy simple? I don't know. You know, I see that this is 10 squared to the x power equals 10 cubed. If we wanted to do it like that, we could. So that way 2x is 3. So then in turn x is 3/2. But even this can get messed up, right? Because you have to make sure that, so first of all, 100 and 1,000, 100 to some integer power is not 1,000. And people may not recognize that they would have to simplify both sides to do this. What will always work, so that way you just have one strategy, is that x is log base 100 argument 1,000. And then instantly it would be the natural log of 1,000 over the natural log of 100. You can just put it in your calculator. It'll tell you that it's 1.5. So there's just so many different paths to get it done. I really and truly hope that everyone was able to put this one in their heart and keep it for in the future, because if you learned anything about logarithms, it was this strategy. And there's at least one more way that I would do this. Huh?
I was going to say, how would you answer it with the solution set?
3 halves. Because look, the natural log of 1,000 is the natural log of 10 cubed. And the natural log of 100 is the natural log of 10 squared. Well, those are exponents, so they can come down out front. You'd have 3 times the natural log of 10 over 2 times the natural log of 10. The natural log of 10 is canceled. Either way, you're getting 3 halves. So whether or not you typed it into your calculator, the natural log stuff, or if you had found common exponential bases, or if you pursued a simplification after doing a change of base.
Does it have to be entered as a fraction? Can it be decimal?
It does not say. I would play it safe and put it as a fraction. I'd bet money that whatever your answer should be is that it is rational, that it can be a fraction. What do you got?
16 to the x equals 32.
Yeah. So we know that this would be x equals natural log of 32 over natural log of 16. So now I'm separated from this idea, so now I can take a step back and say, I know what x is, it's this number. Push came to shove, type it in my calculator. But 32 is 2 to what power? It's 32.
Is it 4? Sorry, no, that's not right.
It's 5.
Yes, 5.
So you have natural log of 2 to the 5th power over natural log of 2 to the 4th power.
So it'd be 5 over 4.
5 over 4.
Thank you.
Yeah. Solve the following equation. What do you think? I can proceed several different ways. Let's just stick with the,
I was going to say natural log 2.
Yeah,
over
that
natural
sounds
log
fine.
4.
natural log of 2 over natural log of 4. Now you can take a step back and look at 2 and 4. 4 is 2 squared. So it's 1/2. And finally, the last one. An important property of logarithms. I don't know how useful it would be for y'all, but it's there. It's peculiar that the logarithm is the only such function that behaves this way. We would use the words that logarithms map addition to multiplication. We have this property that log of AB is log of A plus log of B. And the logarithm is the only function that can do that. It's called a some kind of homeomorphism, something like that. Anyways, that here I have multiplication, here I have an addition, and I have this sum over here, and here's just the one thing. And it's a big deal to mathematicians better than me to.
So would it be log B7 with parentheses x minus y?
No. Because look at what happens here. This doesn't say a plus b, it says a times b.
Right, I only mentioned, okay, yes.
Right? So then if here I had a over b, then that would mean over here it would say, well, my a over b would need to get converted to log of a times b to the minus 1. And then I could use this very same property to get log of a plus log of b to the minus 1. And what happens to that minus 1? Doesn't fall off, it
Yeah.
comes down out front. So it says log of a minus log of b. You got a minus there. So trace it back, what would happen? I would never, but can, write that this is log base 7x plus log base 7 of y to the minus 1. Well
So
then,
it would be log base 7x over b, or over y.
yeah.
Okay.
Says I missed something. Number 13. Let's see what happens. What did we do wrong? Was I not careful enough? I was not careful enough. I ended up at minus 6 instead of minus 7 with my cursor. So be more careful than me. And I guess if that happens to you, always just holler.